So today we're going to be looking at modeling trig functions. Now, in reality, when we see a pattern that moves up and down, when we see some sort of wave, what we know is there's some sort of cycle going on in the background. Either energy is ebbing and flowing, trying to find some sort of equilibrium, which means that we're looking at some sort of oscillation around a point. Ideally, in this case, some sort of circle is going on in the background. So let's take a few examples over today and kind of see how we can take these wave functions and turn them into either a sine, a cosine, or a tangent. The ones we're doing today are simply going to be either sine or cosine. We're not actually doing any tangent functions to start off. But let's go ahead and jump in with number one. So number one, we're gonna try and figure out which function we can use to make this. So because we're dealing with sine and cosine, let's go ahead and off to the side, let's mark down our cosine values and our sine values. So with cosine, actually let's zoom out just a bit so we can catch all of that all in one. With a cosine value, our basic function that we saw is going to be a cosine of b x minus h plus k. This is going to tell us our left-right, our up-down motion. It's going to tell us our period, or lead us to our period, and then our amplitude and our original direction of the graph. Sine is going to be a very similar function. A sine b x minus h plus k. With all the same information, the only difference is with sine versus cosine is we're going to start at a slightly different spot. They both are identical waves. This could be a sine or a cosine wave. It just depends on our starting point. So the cosine, what we're going to do is we're going to trace our first given point that is either at a peak or at a trough. And what we see right here is I see that I have a peak right here at what looks like 0.5 comma 3. That's where my peak starts. And if I trace it all the way around and trace one full iteration of this wave, it's going to help me determine my period. And I have this point over here at 2.5 comma 3. I notice the graph took a full 2 units to get back to its regular part. So with my cosine, I'm going to start fleshing out some of this information. I'm going to say, okay, my period is 2. And if I know my period is 2 pi divided by b, that's going to give me 2 pi is equal to 2b, or pi is equal to b. I know that my b value is going to be equal to pi. And let's actually write out what we don't need. Awesome. So I know my b is going to be pi. The second thing is I need to know left, right, and up-down motion. Now, I've traced out this value, but my left, right, and up-down motion, left, right isn't going to be too big of a deal. How far left to right has this graph moved? Well, it's moved to the right by about 0.5, which means I'm going to subtract 0.5. Actually, let's do this like this, minus 0.5. I've got that. The up-down is what messes a lot of people up with cosine. We're not actually going all the way up to 3. I'm going all the way up to the midline, which in this case is the middle of this wave. What is the wave attempting to either circle or reach if it flattened out? And it would be this value. Everything below would rise, everything above would fall. And so I'm not going up to 3, I'm only going up to 2. So plus 2. The last thing I'm going to look at is the amplitude. I'm going to say from that midline to the peak, how high up did we go? Well, we only went up by a total value of 1. Then I'm going to check the sign of the value. If I went up on a cosine, that's a positive. If I went down on a cosine, that would be a negative. So from my midline to my first extreme point is going to be an upward motion, so that's actually going to be a positive. You don't need to write the positive value, but that's going to tell us what we've got. So that is one possible formula for this cosine graph. You might ask, well, what happens if you started at this point? Well, everything about this would be the same, but our h would be slightly different. So you could conceivably have something that looked like this. we could have a 1 cosine of pi x minus, let's see, 2.5 plus 2. And that would be a valid equation as well, as long as we have the correct amplitude and signage, the correct period, upward motion, and then left-right is just where we start. Seeing as the function continues, it's not going to stop with left-right motion. If I were to do sine, the process would be almost identical. Instead of finding an extreme maximum or minimum point, I would find my first midline point, which would be this one. And I would trace the graph and say, okay, how long until I go upward through the midline? I'm going downward through the midline here, so I know I'm going to keep going. And then I go upward to the midline there, which in this case I go from 2 to 4. If I sketched out my period from 2 to 4 is going to be the exact same, 2. 2 pi over b is 2, which means 2 pi is 2b, or pi is b. So I'd have pi sine. My amplitude would be the same. It still has an amplitude of a positive 1. My height, or my vertical displacement, would still be the same. I'd still be moved up 2, so that'd still check out. The only thing, again, that would be different would be my h. How far left or right have I moved? Well, I've moved right 2, so minus 2. There we go. So we see it's not so bad. You can have multiple iterations of the same function. In fact, these are completely different identities. This is a sine function, this is a cosine function, but they represent the same shape on the graph. So now that we've seen one of those, go ahead and take a shot at number 3. Pause the video and pause it when you're done and see how you did. Okay, so let's try it out. So cosine versus sine. Sine I know is a, sine b, x minus h, plus k. I know cosine is the same thing, just with cosine. A cosine of b, x minus h, plus k. So I'm going to take a look at this, and I notice that I only have extreme values, which means, albeit I would like to use sine, I don't know any information on sine. So there are no known midline values. So I'm going to go ahead and cross this one off. Doesn't mean you can't use it, especially if I wasn't given points. I would have to interpolate some sort of point in there, and I would go ahead and guess, but I have known extreme values. So let's go ahead and flesh this one out. Cosine, figure out what we've got going on. So if I find my first extreme value, right there, and I'm going to trace it until I have another extreme value, of which I don't have a known extreme value, so I'm going to have to go to my next one. And so let's see, I'm going to trace it to my next extreme value. I have another value right here, but there's nothing known. And I have another value down here, and this is known. So albeit it took me a little bit to repeat, I'm going to just say that this is equal to 2 periods. So 2 periods is equal to 5 to 7, 7 to 9, a length of 4. I know that a period is 2 pi divided by b. I'm just going to go ahead and solve for b, which means 2 pi over b is equal to 2, or 2 pi is equal to 2b, or pi is equal to b. We got the same period this time. So my b is pi. So now that I figured out how long it takes for the graph to repeat itself, I got to do some tracking of the midline. Okay, so I have my midline, and now I could use this, or this point to build my equation. It doesn't really matter. In fact, all three of them all have the same amplitude. It looks like from 2 to 2.5, so 0.5 as far as the amplitude. And because the midline is uniform throughout, they're all going to be moved up by 2 units. The only difference between this, and this equation is going to be my h. So in this case, if I start with my first one, my h is going to be a 2. So minus 2, and we got that. Boom. There we go. And so that leads us to another set of problems, like on number 5, where instead of being given a set of data, we have to model this data and see, okay, previously we had a computer-generated image where even our guesses would be really good. This is going to be more realistic, where sometimes our guesses are pretty bad. So let's take a look and see if we can't graph a few of the pieces that we've got. So on number 5, I'm going to graph time and height. Time is the universal dependent variable or independent variable, so I'm going to graph my time on my horizontal axis, which means that what is left up here is going to be my height. And if I know time and height, time I only need to go to 2.4, which that'll take up very little of the graph, so why don't I spread this out? I'm going to count this by halves, or 0.5s. My height, I only need to go up to what looks like 3. So again, I'm going to do this by halves, and that should spread things out a little bit. I'm going to pop a few points, so 0, half 1, a little over a half, so that's 1, half 2, right there, half 1, and then half 1, half 2, half 3, 1.4, half 1, half 2, half 1, half 1, half 2, half, so just before that, half 1, half, boom. And so when we've graphed this, what we're going to try and do is we're going to try and connect this the best way possible. I notice that I have 2 points down here, and I could try and squeeze in some peaks and some troughs in some weird ways, but I think the most natural way for us to look at this is to assume that the highest and lowest points are both a peak and a trough. Now, I could continue this on, but again, it's not known information. I expect what looks like 1, 2, 3, 4, about every 4 for it to repeat. So 1, 2, 3, 4, which would mean 1, 2, 3, 4. I'm expecting for it to look something like that. But this is extrapolation, not really sure on anything that's pink. What I'm going to do is I'm going to check out and say, hey, do I know any information on either sine, which is a sine of b x minus h plus k, or do I know more information on cosine, which is a cos of b x minus h plus k. And so I have what looks like peaks and troughs, which I know is again going to be cosine. I don't have any information on this middle. I could guess where the middle is, but guessing where the middle is not going to lead to a very reliable set of data. And this is a really, really good guess. And this information, this is hand-drawn. I don't know if I trust my drawing that well to be able to guess where the sine would be. So because there's no midline, so no known midline points, I'm going to go ahead and get rid of the sine function. I'm going to stick to the cosine function. So cosine function, it looks like I go all the way up, and then I come back down. And that takes a total of half 1, half 2, which means my period is 2 units long. And if my period is represented by 2 pi divided by b, I'm going to solve for b. So 2 pi is equal to 2b. Pi is equal to b. I swear I didn't do this intentionally, but we got what we got. So my b in this case is going to be a pi. So cosine of x, there we go. Let's check out our amplitude. From the midline, I'm going up half one, but I am starting at the bottom down here, so I'm going to make that a -1. If I started at this point, it'd be positive, but I'd have a different h value. So if I'm starting right here, I haven't moved left or right, so I'm going to go ahead and get rid of the h, because that'll be a 0. But the k is half 1, half 2. Boom. And we get that information as our answer. So you can see overall it's not too bad. So what I want you to do is I want you to go ahead and pause the video, and I want you to try number 7, unpause it when you're done, and see how well you did. Okay, let's take a look. Number 7, the first thing we're going to be doing is I'm going to be graphing an axis. I see nothing but positive numbers, so I'm going to go ahead and put my axis over here. I know I have time and I have height. Time is relatively short, so I'm going to count this in halves. Height, I'm going up and down to 7, so I'm just going to go ahead and count this by ones. Plot some values here. So 0, 2, 4, 6, and 7. So half, 1, 2, 3. Over 1, 4, 5, 6, 7. Half is 3. 2 is 7. Half is 3. Which means that this graph is bouncing back and forth quite quickly. And I could extrapolate that same pattern is going to continue. But again, it's extrapolation, not necessarily very reliable. So let's take a peek at what we know. Do we know any midline functions? Nope. So we have no known midline points. I'm going to yet again stick to a cosine graph. A cosine of b, x minus h plus k. Okay. My first known value, I'm going to trace it down. There we go. So in this case, we have a period of, let's see, going by halves, so half 1. So our period is 1. So 2 pi over b is 1. So 2 pi is equal to b. Awesome. So we got 2 pi is equal to b. The next thing is we're going to need to graph that midline. I'm going to pop it right here. Because I notice the distance between 3 and 7 is going to be a midline of 5. Take that high point and low point, add them together, and divide by 2. So 1, 2, 3, 4, 5. Yep. Which means the graph has been moved up by 5. No left or right motion. And I'm starting at a peak, which means this is going to be a positive whatever, and then my amplitude is going to be 2. And there we go.